China just shocked the world with what they are building on the moon. But here is what almost nobody is paying attention to. This is not about planting a flag and going home. China is building a permanent lunar base, complete with 3D printed buildings made from moon dust, robots that assemble structures like Lego blocks, and a reusable rocket they already flight tested 2 months ago. And they are not doing it alone. More than a dozen countries have already signed up to help. If you think the space race ended in 1969, you're about to find out it just restarted. And this time, China is winning. Let's start with what happened on February 11th of this year at the Wenchang space launch site in southern China. Because that single day changed everything. China launched a prototype of its brand new Long March 10 rocket, a super heavy lift vehicle designed specifically to send astronauts to the moon. Mounted on top was a prototype of the Mengzhou crew capsule, the spacecraft that will eventually carry Chinese taikonauts to the lunar surface. During the flight, engineers deliberately triggered an emergency abort at the most dangerous moment of launch, a point called maximum dynamic pressure, often referred to as max Q, when aerodynamic forces on the rocket are at their absolute peak. The capsule fired its escape motors and separated cleanly from the rocket. It splashed down safely in the ocean. And then something remarkable happened. The rocket's first stage didn't just fall into the sea like a piece of debris. It reignited its engines, oriented itself vertically, and performed a controlled powered descent into a designated ocean zone. Recovery crews picked it up. Think about what that means. China now has a reusable crew-rated moon rocket that can land itself. The first stage uses grid fins and a tether-based capture system designed for future landings on solid ground. Similar in concept to what SpaceX does with Falcon 9, but designed from scratch for lunar missions. The full Long March 10 stands 92.5 meters tall and can lift 27 tons to a translunar trajectory. That's enough to send both astronauts and a lunar lander to the moon in a 2-launch architecture. And the infrastructure to support it is almost ready. The new launch tower and pad at Wenchang are expected to be fully operational by the second half of this year. But the rocket is just the delivery system. What China is actually sending to the moon is far more interesting. Scientists at the Deep Space Exploration Laboratory in Hefei have built the world's first machine that can produce construction bricks from lunar soil using nothing but concentrated sunlight. Picture a large parabolic mirror, the kind you might see at a solar power plant, but designed to work on the moon's surface. This mirror gathers sunlight and channels it through fiber optic cables to a single focal point. At that point, the light concentration exceeds 3,000 times normal intensity. The temperature at the tip reaches over 1,300 degrees Celsius. That is hot enough to melt lunar regolith, the fine gray powder that covers the moon's surface. A 3-dimensional printing mechanism then shapes the molten material into solid bricks of various sizes and specifications. No water, no chemical binders. No materials shipped from Earth, just moon dirt and sunlight. The researchers spent 2 years perfecting the prototype because lunar soil composition varies dramatically across different regions of the moon. They had to develop simulated samples from multiple lunar environments and test the machine against each one to make sure it could adapt. And here is the part that most people missed. China did not just build this machine in a lab and call it a day. They actually sent a batch of these simulated lunar soil bricks to the Tiangong space station aboard the Tianzhou 8 cargo spacecraft in November 2024. Those bricks spent a full year outside the station, exposed to the vacuum of space, extreme temperature swings, and cosmic radiation. They returned to Earth in late 2025 aboard the Shenzhou 21 spacecraft. Initial inspections showed the samples survived remarkably well. That is real-world validation of a construction material designed for another world. And the bricks are only half the story. A team at Huazhong University of Science and Technology in Wuhan has built a 6-legged construction robot called the Lunar Spider. This insect-like machine is designed to take those 3D printed bricks and assemble them into structures on the lunar surface, snapping them together in interlocking patterns similar to Lego pieces. The goal is a fully autonomous construction pipeline. One machine makes bricks from the ground beneath it. Another machine picks them up and builds walls, roads, and radiation shields around habitat modules, all without a single human hand touching a piece. The bricks serve as protective outer layers for pressurized habitat modules that would be delivered from Earth. Together, the bricks and the rigid modules form a complete shelter, shielded from micrometeorites and the intense radiation that bombards the lunar surface. China envisions this system as the backbone of every structure at its planned lunar base. Now, before any of that construction equipment lands on the moon, China needs to scout the territory. That's exactly what Chang'e 7 is designed to do. This mission launches later this year, and it's heading straight for the moon's south pole, a region that space scientists consider the most valuable real estate in the entire solar system. The South Pole has permanently shadowed craters, areas that haven't seen sunlight in billions of years. Inside those craters, scientists believe there are massive deposits of water ice. Water on the moon isn't just about drinking. You can split it into hydrogen and oxygen. The oxygen is breathable air. The hydrogen is rocket fuel. A reliable water source on the moon means you don't have to launch everything from Earth. It means the moon becomes a gas station, a supply depot, and a launch pad for deeper missions to Mars and beyond. Chang'e 7 is bringing serious hardware to investigate. The mission includes an orbiter, a lander, a rover, and a mini hopping probe. That hopping robot is specifically designed to jump down into those permanently shadowed craters where regular rovers can't go. It will search for direct evidence of water ice and send back data on the composition of the soil. The mission also carries 6 international scientific instruments from partner countries, including an AI-enabled camera from Egypt and a science payload from Thailand. This is not a solo operation. And that brings us to Chang'e 8, the mission that could change everything. Scheduled for 2028, Chang'e 8 is the construction test mission. This is where China actually attempts to 3D print bricks on the lunar surface for the first time in human history. The solar-powered brick-making machine, the Lunar Spider robot, and a suite of resource utilization instruments will all ride on this spacecraft. If the technology works as tested, China will have proven that humans can build structures on another world using only local materials. That's not a scientific milestone. That's a civilization-level breakthrough. It would mean that permanent lunar habitation isn't a fantasy. It's an engineering problem with a working solution. Chang'e 8 will also verify communication systems between the moon and Earth, including plans for wireless networks on the lunar surface. According to officials at the China National Space Administration, there will be wireless internet connectivity on the moon. Scientists are even researching whether it's possible to grow vegetables there, with Chang'e 8 potentially carrying biological experiments to test the idea. All of this feeds into China's grandest space ambition, the International Lunar Research Station. Known as the ILRS, this is a permanently crewed base planned for the moon's south pole. As of early 2025, 17 countries and over 50 international research institutions have formally signed on. The partner list includes Russia, Pakistan, South Africa, Egypt, Thailand, Venezuela, Belarus, Kazakhstan, Serbia, and Senegal, among others. China and Russia jointly announced the project in 2021, positioning it as a direct alternative to America's Artemis program. The ILRS is planned in 2 phases. Phase 1 is a basic research station at the South Pole, operational by 2035. This station will conduct scientific operations within a 100-kilometer radius, using an integrated Earth-Moon information network that connects unmanned exploration missions, crewed landings, and international partner payloads into a single interoperable system. Phase 2 is far more ambitious. By 2050, China plans to expand the ILRS into a network of stations spanning the South Pole, the lunar equator, and the far side of the moon, connected by a lunar orbital station serving as the central hub. That's not a moon base. That's a moon civilization. Now, none of this is happening in a vacuum. Pun fully intended. The United States is running its own Artemis program to return astronauts to the moon, and the 2 nations are essentially racing each other. But there is a critical difference that most people do not appreciate. NASA's Artemis has been plagued by delays, budget disputes, and shifting political priorities. The program has been restructured multiple times since its announcement. In late February of this year, NASA inserted a new mission into the Artemis sequence, pushing the timeline for a crewed lunar landing to 2028 at the earliest. The Space Launch System rocket has cost roughly $50 billion in development, and it is not reusable. Meanwhile, China's lunar program has followed a steady plan since 1992, a 30-plus year roadmap called Project 921 that has been executed step by step regardless of leadership changes. Every milestone has built on the previous one. Chang'e 1 orbited the moon. Chang'e 3 landed on it. Chang'e 4 landed on the far side, a world first. Chang'e 5 brought back samples. Chang'e 6 brought back samples from the far side, another world first. Now Chang'e 7 and Chang'e 8 will build the foundation for a permanent base. NASA Administrator Jared Isaacman put it bluntly at a conference in February. He called China our great rival and warned that if China lands taikonauts on the moon before the US returns, the damage to American leadership in space could be irreversible. But here is what makes this about more than national pride. The moon contains resources that could reshape the global economy. The most talked about is helium-3, a rare isotope that is vanishingly scarce on Earth but relatively abundant in lunar soil. Helium-3 is considered the ideal fuel for future nuclear fusion reactors, a source of clean, virtually limitless energy. Some estimates value the moon's helium-3 deposits in the trillions. Then there are rare earth elements, titanium, iron, and other minerals embedded in the regolith. The nation that builds the infrastructure to extract and process these materials on the moon does not just win a space race, it gains access to a resource base that could power industries for centuries. This is why China is not just sending robots and flags. They are sending brick-making machines and construction robots and communication networks. They are building the tools to stay. Perhaps the most telling indicator of how serious China is about all of this came from a quiet announcement about their astronaut training program. China's taikonaut candidates for the lunar missions are already in training. The Lanyue lunar lander, the vehicle that will carry them to the surface, completed a full-scale landing and takeoff verification test in August 2025 at a dedicated extraterrestrial landing test site in Hebei province. The Mengzhou crew capsule has been through pad abort tests, high-altitude escape tests, and now the full-flight abort test from February. The lunar suits called Wangyu are in development. China is already designing a crewed lunar rover called Exploration that will let astronauts drive across the surface to conduct experiments and survey potential base sites. Every single piece of the puzzle is moving forward simultaneously. The rocket works. The capsule works. The lander works. The brick machine works. The construction robots exist. The launch pad is nearly finished. The international partners are signed. The only thing left is to do it. The question everyone should be asking right now is not whether China can build a base on the moon. It is what happens to the rest of the world when they do. The first nation to establish permanent infrastructure on the lunar surface will set the rules for how that surface gets used. They will decide who gets access, what gets mined, and how lunar resources are distributed. The moon is about to stop being a symbol of human achievement and start being a strategic asset. And right now, China is building there faster than anyone else on Earth. Whether that future unfolds through competition or cooperation is still an open question, but the construction has already begun.